Hello students, let's study the next unit of class 12th, current electricity. In the first unit, you have studied about the charges at rest, and in this unit, we will study the charges in motion, and the topics which we will study in the first part of this unit are shown on the screen. If two bodies charged to different potentials are connected together by means of a conducting wire, charges begin to flow from one body to another. The charges continue to flow till the potentials of the bodies become equal. Therefore, the electric current is the charge flowing through any section of the conductor, and mathematically, it will be Q upon T for the charge steady, and if rate of flow of charge varies with time, then it will be I is equals to delta Q by delta T, limits delta T tends to 0, and that will become dQ by dt. The SI unit of current is ampere, and 1 ampere current flows through a conductor when 1 coulomb of charge crosses an area in 1 second. Now, different types of current. Let's plot an IT graph. The A part of the graph represents that the steady currents, means which doesn't vary with time. Now B and C curves represent varying current whose magnitude changes with time, and this D curve represents the alternating current whose magnitude varies continuously and direction changes periodically. And about alternating current we will study in detail in the next unit. By convention, the direction of motion of positive charge is taken as the direction of electric current. However, a negative charge moving in one direction is equivalent to an equal positive charge moving in the opposite direction, as shown in the figure. And the electronic current, due to the motion of electrons, is in the direction opposite to that of the conventional current. Although electric current has both magnitude and direction, yet it is a scalar quantity because it doesn't follow the laws of vector algebra. A device which maintains a potential difference between its two terminals is known as a battery or a generator or thermocouple, etc. Here, EMF stands for electromotive force. Note that the name represents electromotive force, but it is not a force. The electromotive force of a source is the amount of work done by the source in taking a unit positive charge from lower to higher potential. Here in the figure 3, internal structure of the battery is represented. Due to certain chemical reactions, a force is exerted on the charges of the electrolyte. This force drives positive charges towards terminal P and negative charges towards terminal Q. Suppose the force on a positive charge Q is Fn. As the charges build up on the terminals P and Q, a potential difference is set up between them. An electric field E is set up in the electrolyte from P to Q, and therefore this field exerts a force Fe equivalent to QE on the charge Q in the opposite direction to Fn. And in the steady state, the charges stop accumulating further when Fn will be equivalent to Fe. And the work done by the non-electrostatic force during the displacement of charge Q from Q to P is W is equals to Fn into D, where D is the distance between the terminals P and Q. Therefore, the work done per unit charge is E equivalent to W upon Q, and that will be equal to Fn D by Q as written in equation 2. Here, the quantity E is known as EMF of the battery, and for the steady state, it will be equivalent to V. That means VA equivalent will be equal to E into D is the potential difference across the terminals of the battery between P and Q when the circuit is open. Here are the points of difference between EMF and potential difference. Note that the EMF, that means electromotive force, is the work done by a source in taking a unit charge once around the complete circuit, whereas the potential difference is the amount of work done in taking a unit charge from one point of a circuit to another. So you can say that the EMF is a cause, whereas the potential difference is an effect. EMF is larger than the potential difference across any circuit element, whereas the potential difference is always less than the EMF. Only the potential difference is higher than the EMF when the cell is being charged. And EMF is independent of the external resistance in the cell, whereas potential difference is always less than the EMF. Thank you.